We're going to solve and graph the solution set for 2x over x plus 1 greater than or equal to 1. So this is my fourth installment in this series. The difference this time is I have a rational inequality. So it's going to be a little bit different, but it's really not. The hardest part is getting it set equal to 0 and then solving. So again, we want to get it set equal to 0 as I just indicated, so we're going to subtract 1 from both sides. So that's going to give me 2x over x plus 1 minus 1 is greater than or equal to 0. Now, in order to subtract these, remember, we're going to have to find a common denominator. Well, the second one is over 1, so the common denominator is going to be that x plus 1. So this is going to be 2x minus x plus 1 over x plus 1 is greater than or equal to 0. And then when I combine my terms, I'm going to get 2x minus x is x minus 1 over x plus 1 is greater than or equal to 0. Now, with rationals, it's a little different. Remember, to find our boundaries, we're going to have to set the numerator as well as the denominator equal to 0. So that is the one catch for the rationals. So that's going to give me x minus 1 is equal to 0, and x plus 1 is equal to 0. So x will equal to 1, or x will equal to negative 1. Okay, so now it's exactly like we've been doing. You're kind of home free. We're going to draw our number line. I've got a minus 1. And I've got a positive 1. So again, we're going to have 3 intervals. I need to pick a number in each one of those. So less than minus 1, let's do minus 2. Remember, if you can pick 0, you want to. So this one is 0. And then we want to pick a number greater than 1, and I'm going to say 2. Now, if you pick something else, that's fine. Just make sure that you get the same yes and no or true and false when you solve them. So what I want you to do, as usual, is to pause the video, do your calculations, come back, and check with what I've got. Welcome back. Hopefully you've done your math and you've solved, and now you notice that there are 2 intervals that are true, and we notice it's the one where we chose the minus 2 and the one where we chose the 2. So first I need to write that on a number line correctly. So I'm going to have the minus 1 and the 1. We said it's this interval, remember it's equal to, so it's going to get your square bracket, and then we're going to go to the left, and then we're going to get a square bracket, and we're going to go to the right. Now, how am I going to write that in interval notation? Well, I'm going to write that as negative infinity to minus 1 equals, or from 1 to infinity. Now, I'm looking back over my answer, and I'm thinking, uh-oh, we have a problem, don't we? Because we said originally that when the bottom was equal to 0 would be the x plus 1, so that means that x can't be negative 1. So remember, we're looking here. So actually x cannot be negative 1. That's really important. But what did we do over here? Well, I included it, correct? So that's a mistake, and that's going to happen, and that's okay. So what we're going to do is I want to change the square bracket over here on the minus 1 is now going to be actually an open. Because remember, we just said it cannot include that because it makes the denominator 0.